Okay, welcome back everybody one last time to our Chapter 14 notes in Calculus 3. We're on the last example in section 14.9, thus the last example for Chapter 14. This is example 75. So we want to find a quadratic approximation to f of xy equals sine of x times sine of y near the origin. And then we want to talk about how accurate is the approximation if absolute value of x is less than or equal to 0.1 and the absolute value of y is less than or equal to 0.1. So we're always going to stay within 0.1 in this rectangle near the origin. Okay, so this is the quadratic approximation is this first row, first line, and then this term is then the error term. Okay, so we need all the second order derivatives, so I'm going to go ahead and find the function's value at 0, 0, the first partial respect to x at 0, 0, first partial respect to y at 0, 0. Those are all 0. So then these first three terms are 0. And then the second partial of f with respect to x at 0, 0 is also 0. And then the mixed partial of f with respect to x then y is 1. And the second partial of f with respect to y is also 0. So what happens is the only term that survives in the quadratic term is the 1/2 times 2xy times 1, so just the sine of x times sine of y, which is just x times y. So sine of x sine of y is approximated near the origin. Its quadratic approximation near the origin is x times y. Now the error in the approximation is this third term, okay? Evaluate at some cx cy that is on the rectangle of interest, okay? So we want to find what's the maximum value of this essentially. Okay, so in other words, I have to go through and then I actually don't need to take all these derivatives because they're all going to be combinations of sine times cosine or sine times sine or whatever, right? So the most any of these third order derivatives could be is 1 because the most a sine function can be is 1 and most a cosine function can be is 1. So these are all restricted to have upper bounds of 1. I'm talking about the third order derivatives. All right. And then, since absolute value of x is less than or equal to 0.1 and absolute value of y is less than or equal to 0.1, that means that the entire error, absolute value of it, is less than or equal to 1/6 times 0.1 cubed plus 3. This is 0.1 squared times 0.1, so it's still 0.1 cubed, plus 3 times, again 0.1 cubed, plus another 0.1 cubed. So it's actually 8/6 times 0.1 cubed, which is less than or equal to 0.00134. So the error that we would see on that rectangle, this rectangle right here, absolute value of x less than or equal to 0.1, absolute value of y less than or equal to 0.1, the maximum error we would ever see is 1/1000th, which is pretty amazing that xy gives that good of an approximation of sine x times sine y.